Efficiently sum a small numpy array, broadcast across a ginormous numpy array. I want to calculate an indexed weight sum across a large, 1,000,000 x 3000, Boolean numpy array. The large Boolean array changes infrequently, but the weights come at query time, and I need answers very fast, without copying the whole large array, or expanding the small weight array to the size of the large array. The result should be an array with 1,000,000 entries, each having the sum of the weights array entries corresponding to that row's true values. I looked into using masked arrays, but they seem to require building a weights array the size of my large Boolean array. The code below gives the correct results, but I can't afford that copy during the multiply step. The multiply isn't even necessary, since the values array is Boolean, but at least it handles the broadcasting properly. I'm new to numpy, and loving it, but I'm about to give up on it for this particular problem. I've learned enough numpy to know to stay away from anything that loops in Python. My next step will be to write this routine in C, which has the added benefit of letting me save memory by using bits instead of bytes, by the way. Unless one of you numpy gurus can save me from Python?
The dot product, or inner product, is what you want. It allows you to take a matrix of size m times n and a vector of length n and multiply them together yielding a vector of length m, where each entry is the weighted sum of a row of the matrix with the entries of the vector of as weights. NumPy implements this as array1.array2, or numpy.array1, array2, in older versions. For example, you should benchmark this though, using the timeout module.
It seems likely that Bab's answer is the correct one. But just for the sake of diversity, here's another solution that saves memory. This will work even for operations that don't have a built-in NumPy equivalent. numpy.lib.stride_tricks.is_strided is a wonderful little function. It allows you to specify shape and strides values that allow a small array to mimic a much larger array. Observe, there aren't really 4 rows here, it just looks that way. So instead of passing a huge array to masked array, you can pass a smaller one. But as you've already noticed, NumPy masking works in the opposite way you might expect, truth masks, rather than revealing, so you'll have to store your values inverted. As you can see, masked array doesn't copy any data, it just reflects whatever is in weights_stretched. Now we can just pass it to sum. I benchmarked numpy ... in the above against a 1,000,000 by 30 array. This is the result on a relatively modern MacBook Pro. numpy ... is .1, mine is .2. As you can see, the built-in NumPy solution is faster. But stride_tricks is worth knowing about regardless, so I'm leaving this.
Would this work for you? This uses sum to immediately sum the row weights values, so you don't need the memory to store all the intermediate values. Then the list comprehension collects all the values. You said you want to avoid anything that loops in Python. This at least does the looping with the C guts of Python, rather than an explicit Python loop, but it can't be as fast as the numpy solution because it uses compiled C or Fortran.
I don't think you need numpy for something like that. And 1,000,000 by 3000 is a huge array. This will not fit in your RAM, most likely. I would do it this way. Let's say that your data is originally in a text file. My code. Result. Edit. I think I slightly misread the question first time around, and summed up the everything together. Here is the solution that gives the exact solution that op is after. Result.
Let's walk.